Alright, here we go. So we had a base class that was called shape. We had, I'm going to get rid of the private and protected business. Just leave everything at default for now so we can focus on overloading. We had a default constructor that set both of these values to something, in that case 0, and then we had a 2-argument constructor that we could create a shape setting x and y as they are needed. We had accessors. We talked about all of that, right? Any questions about any of that?
No.
And we said that shape is kind of abstract. To say that, you know, we create a shape, what does that mean? There are different shapes, they look different, they're different sizes and things like that, different properties. So we said we could create a circle and that would extend shape. Circle is a shape. So it will inherit the x and y from above, but it will also provide some things of its own, like a radius. I don't know why we gave it a name, but whatever. Anyway, so yeah, circle, x, y, and a radius. And the rectangle had the height and the width. And that was pretty much it. Here we use the super keyword. Super has to be the first line of a constructor, but then we could use that to call a constructor that is higher up the tree. Any questions on that? Does that make sense?
Yes.
All right. That's good. Now, moving on to overloaded methods. In shape, we might want a method for drawing things. But how would you draw a shape? Tell you what, we're not actually going to do the graphics, but let's just do a cout statement or a print line statement. Something there to let us know that this method was executed. Let's see if that works. If I come down here and I say C for my circle dot draw, I inherit draw from shape, and I run that. Yeah, shape draw. I got my output down here. That works just fine. But what if we want circle to draw differently than other shapes? Does that make sense? So we can provide circle its own draw method. So now when I run the program, it should execute this one instead of this one. Let's see if that's true. Totally true. Now, in Java, it is customary to add an annotation here. When you override a method, you don't have to. It will compile and work without it, but it can save you some headache. And you'll even see NetBeans puts a little light bulb up there with a caution sign that says, hey, would you like to add this annotation? You're like, yeah, do that thing. And it's basically the @ symbol with the word override. And that just lets you know, it's kind of like a special comment that this circle or this draw method overrides the base class draw method. Let's write one for the rectangle. we can do at override void draw Now let's create a rectangle. Now that works just fine. So overriding is not complicated. All you're doing is providing your own implementation for some class. The base class will have some version of the function, but if you want to provide your own, that's an override. You're overriding the base class. Simple enough?
Yes.
All right. Let's keep going. I don't have a default constructor for circle, but is this valid code? Can I do that?
Looks like it.
You're trusting the IDE?
Yes.
Throwing caution to the wind, I'm not trusting.
No, that would be you trust everyone. You're throwing caution to the wind. Anyways, a circle is a shape, so I can say this. I can say I have a shape variable and it is a circle.
Cool.
Right? I can say, just like in C++, we have in advanced C++, most of you are in that class, we have a state pointer, right? And it can point to different states because they're all derived from state. Here we have base class shape, and we have a circle that is derived from that, a rectangle that is derived from that, basically the same thing. These are reference variables of the base class, therefore they can be set to equal anything that is derived from the base class. Really cool?
Yes.
So if I do a.draw here, b.draw, it still knows how to go draw the correct one.
Would there be a particular advantage of declaring your variables that way, or is it just like a stylistic choice?
There's sometimes advantage, like the state machine, which we're going to make shortly. And if you just had an array of shapes and you wanted them to randomly be something, you can do that and then it will still draw the correct shapes. Right? I could create an array of shapes. Right, there's 10, an array for 10 shapes, and then I could say that You know, I could roll a random number if I wanted to, and then say, you know, for each one of these guys, let me think of a clever way to do this.
Sir, could you move your cursor?
Yeah, as soon as I figure out what I'm doing.
Oh,
There. Default constructor, so I can just say create circle. There we go. There, how about that? Does that make sense? What are we doing?
If flip is true, you're gonna make a circle, and if it's not, you're gonna make a rectangle.
And then,
And switch it every time.
and then flip it. So, and then I could draw, or call draw, for each one of these guys. So, in dot draw. So what do you expect to see for output? What's that?
5 circles, 5 rectangles.
In that order?
Now it's going to be all.
Should alternate, right?
yes.
So this could have been a random function, right? And I could have several different types of shapes, but I would still just have one array that I'm working with. And if I've overridden the methods that I need to work with just shapes in general, then the computer, the language itself determines what needs to happen with each one of those. That's polymorphism. That is just the ability for this shape to morph into a rectangle or a circle or whatever as needed. N is polymorphic object. Yes.
After your if-else statement, you got flip is set to not flip. What does that mean exactly?
Okay, so flip is a Boolean. It means it can be true or false, right?
Yes.
All right, so I started it at false. If I say this equals not false, what does that mean?
Set to true.
It means it's true. Next time around, I say it equals not true. What does that mean?
Set to false.
Yep.
Okay.
That's how you flip a bool.
Okay.
You can't do that in C++, can you?
You can.
What have I been doing here my life?
We could just say n equals flip question mark new circle colon new rect. And delete all that. That will do the same thing much quicker or shorter. And a little bit harder to read until you get used to those things. But I just want to remind you that's out there. That works the same way.
I remember when we were in, I think it's your class, either your class or Susie's class, and we were showing how to do the for loop that way, and we like all flipped. And you guys were like, what do you mean you don't know how to do this? And we're like, we've never been told this amazing thing.
Oh, the for each loop.
Yeah. Or no, just the for loop like that, not a for each loop.
Well, this is a for each loop.
Is this for each?
You don't use the word each, but that's what it is. In the C# you'll use each, but in C++ and Java you just put the type, the thing in the colon, and then whatever you want to run through, and it will be for each thing in my array called R, do some stuff. And in C++ you can use auto here if you want to, but we don't have auto in Java. Where auto just detects what it is by itself. Here you have to tell it at least it is a shape. Okay, so there's polymorphism in a nutshell. Is that super complicated? Super useful. Save you a lot of time and gives you a cool way to structure your code. This is one way you'll see it used with like a base class array. You've got a base class array of several different objects and they all need slightly different behaviors. Then they will all have overridden methods in there, and you can run them through a for loop and they will all do their own thing without you having to say, hey, if this is a circle, then draw it this way, or if this is a rectangle, draw it that way. It automatically knows. There's no if statement there. We had an if statement for the flip, but that was just for fun, just to show that it can alternate, and we don't know which one is which necessarily without thinking about it, and the computer does. All right, any questions about that? All right, we're going to take 5. I'm going to get coffee because it's an easy little example of a program with multiple states. It has the standard state, the scientific state. All the buttons are different now. Collision detection is different. Clicking here will be different than it was a minute ago. You know, different states of the same program. And the state machines make it easy to split a program up into different sections and maintains efficiency. The other way of doing this, and you may not realize this until you try it, but if you try doing stuff like this without a state machine, you end up writing a plethora, and I mean a long staircase of if statements that check all this stuff all the time, anytime you do anything. And if you start seeing a really long staircase of if statements, it's usually a bad sign. A state machine can help avoid that, and you can write state machines as switches in a lot of cases, but the switch can become pretty unruly pretty quick, and so in some cases it's better to resort to classes. You can break your classes up into different files even if you want to, but you can still create a state machine using classes and polymorphism. So that's what we're going to do here. It's also a great application for polymorphism other than the array of base class variables, because this one is the same thing. We're still using overridden methods, we're still using inheritance, but the application is totally different, so we'll go with that. First thing we're going to need is our base class, which is state. At least that's what I like to call it. base class state, and then normally you will have two functions at least. You'll have an enter function and an update function. And remember, these are virtual. In C++, you have to call these things virtual, but in Java, everything is virtual by default. And if you want it to be non-virtual, you can make it final, and that like locks it up so it cannot be overridden. But default is virtual. All right, what's a state we want to use here?
Menu.
Menu. That's a good one. Class menu. Okay, and the menu will have its, it needs to extend from state. There's our inheritance. And it will have its own version of enter and update. We'll come back and fill in later, but sometimes you have exit. Sometimes it can be good to have exit. Let's do just a print statement so we know this is working. If you want to cheat, you can make a variable up here from print stream. And I don't know, just call it out or something. Print stream like that. And then hold Control Shift and push I, it will include print stream up here. And you can set that to system.out. And then you can just type out dot print or print line. So it's a clever way of being a little bit lazy. Okay, the enter function is going to, normally this is used to initialize any variables that you need for this state. It might be to set everything to false or whatever its default state is. You might want to center your mouse cursor. There's different things you would do here. Whenever we enter this state, we set up everything we need right here. Maybe play the music or something like that. Load in some files. Depending on your application, whatever it is, the setup happens in enter. The update, this is where you will run a main loop. And then you will also check if you need to change to one of the other states. Okay, so that could be a button press, that could be a certain packet or message comes in from the internet or whatever you're checking for. Somewhere you need to know if it's time to change to a different state other than the menu. In C++, we did it with a button press. We push this button, we change to that state. We set up state machines for artificial intelligence for the agents, for like bad guys and stuff. So maybe when their health reaches 0, we change them to a dead state. They play this dead animation, they fade away, that kind of stuff happens. So state machines are used for all kinds of things, but in the update you'll check for your transitions to other states. Alright, and that's the basics, or the basis of it. Normally this runs in a loop. Let's make another state. Lots of programs have options. And I'll just copy, I forgot my override annotations here, but these are both overrides, so that's proper to put that there. Anyways, I can copy this, paste it into options, and we'll just change menu to options, and we'll change menu to options. And typically, it's a little bit weird in Java, so I have to think about this for a second, but we'll get there. There's different ways of doing it. There's not necessarily a right or a wrong, but we need to create an instance of options, and we need to create an instance of menu, and we need like a current state reference variable. So in C++, I might do this here, or at least try it there. If this doesn't work, we'll move it. And then you can set current to one of these two states. But you won't make a new current, obviously. You just set this as a reference variable to whichever one you're using right now. So I was wrong. Follow your conventions in Java. Variables start with lowercase. Alright, we'll say current equals, we'll just start at menu. And then we will run some sort of loop here. All right, that's the general idea. But now, how do we change? Started in menu, how do I change this?
Track current something else.
Change current, but I have to do that from update.
You could do like a change state function inside of it, of the type.
How do I change this guy? So I'm not going to have access to that in that class.
You would need to make it global.
There's not really such a thing as global. This is where the madness ensues. One way of doing this, let's just cut all these guys out and move them up to base class. I don't think it'll let us run new right there. No, can't do that. But we can make a constructor and set them up in there. So default constructor for state. Well, we'll declare the variables up here, but we will make them new in the constructor. Their state options, their state menu, and there's current. Options will equal new options, menu equals new menu, current equals menu. Sorry, little menu. Okay, that would allow me to access these guys from any of the extended states, but I still have a problem here. Does anybody see the problem with this?
I can't see current.
That's one problem. The other problem is when we create any state, when I create a new menu, it will have its own version of options. And when I create a new options, it will have its own version of menu because they are both states, they will both execute the state constructor. So then I have two option states and two menu states and they're not the same. That's a problem. So if I want to create only one option state and only one menu state, how do you do that? Static. If we make them static, there's only one for the entire program, no matter how many states we create. Now, down here for current, we can actually call current against the class name. We don't even have to create a state for it. We can just say base class dot current, call enter, base class current, call update. I think that builds. Okay, main was null pointer. Main was null pointer. Right, because we have not actually created a state yet. So I was wrong down there. We do need to create a state. I guess that's one way of doing it. That will initialize the variables. That should run. No, it doesn't. That crashed and burned. So we left these as static, and we created them, or we declared them as part of the base class, but we initialized them down in main using the class name, the dot operator, and that works just fine. So now we can change states through update. I can say current equals, so I'm in menu, I can go to options, and then from options I can go to menu. We'll just bounce back and forth there. It's an infinite loop, but we see we're going back and forth between the different states. Any questions on that so far? Does that make sense? Maybe. All right, we can make a little more practical. We could create a scanner. Up in state, I will create a scanner. Oh, I can't initialize it there, but I can declare it here. And Control-Shift-I to include it. And then we can initialize the scanner every time we hit enter. So we could say scan equals new scanner. And we'll do that in both states in the enter function. Alright, and then we can create our menu. We'll do a while loop here. We probably need a Boolean for this loop. So up in the base class, I'll create a Boolean called running. So while running, out dot println \n main menu one to go to options, and 2 to exit. Then we'll get our input. We need an input variable. We take these in as integers or as strings. So up in base class, since every class will need an input, I just made it up there. That way they automatically have their own. Here we go. We'll say input equals scan.next or next int. And then you could have a switch or if statements, but typically you do a switch on input. Case 1, current equals options. And running equals false to get us out of the loop. And then case 2, system.exit. To kill the program. If we're going to set running to false, we probably need to, that probably needs to be one of the variables that's initialized on enter, so that way when we come back to this state, it's not still stuck at false. So running equals true, and then we can just take all this information and we'll copy it down into options. I'm going to take my while loop. Well, I'm going to format this guy first. I'm going to take my while loop here, copy that, and paste it down into options. And I'll set running to true here as well. And we'll just change the words up to make it make more sense. Instead of main menu, we're in options. Instead of going to options, we're going to menu. Scanner's still good. Case 1, we don't change to options, we change to menu. Running equals false. 2 will still exit. I think I missed a curly brace somewhere. Okay. So it starts off, we enter the main menu because that's our current state. It says updating menu as expected, and then it gives me my menu options, which I only have 2. But if I put in a 1 for options, it takes me to options. Right, entering option state, so that hit the enter function just fine. We're updating options now, we're in the update, we're stuck in that loop, and we can go back to main menu or we can exit. So let's go back to main menu. That works just fine. Back to options. They hop back and forth just fine, and then if I hit 2 it should exit. Yes. Winner, winner, chicken dinner.